Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 108 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. What I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 107, but I must first ask, how many of you were successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, now this should have been a really easy lesson because I showed you what was the assignment. The assignment was to create a portable distance sensor using the HC-SR04 ultrasonic sensor, and then to use the SSD1306 display so that you have something that you could walk around with that would be sending out pings and then displaying on the little screen what the distance to the target was. Now, how hard could it be? I showed you on the HC-SR04 how to control it with the state machines for ultra precise timing and ultra precise results. I showed you how to do that. And then in earlier lessons, I showed you how to do the OLED. I showed you how to use the OLED. So it was just taking two things that I'd already shown you and bring them together. Should be trivially easy, right? Maybe you guys got in a little bit of a trap. Okay, maybe you stumbled on this, and so never fear, I will take you through my solution. But I really want to know if anybody got it figured out, because really there was a little bit of a stumbling block in there, and there was a little bit of a pitfall that required you to really think through things. But hopefully some of you guys got it figured out. Okay, so what is the assignment? Let me see if I can do a little Windows management here. Give me just a second. I'm trying to get my schematic up. Okay, I think that'll do it. Let me get out of your way, and I will have a little sip of coffee. And let me kind of start by showing you, just showing you physically what I have here. That is not what I meant to click. Physically what I have here, I have the Raspberry Pi Pico W, I have the SSD1306, and then I have the HC-SR04 ultrasonic sensor. Now, specifically how I have this thing hooked up, you can go to the most excellent www.toptechboy.com, and once you are there, you can use this happy little search icon, and you can search on something like portable distance measurement project, and with the HC-SR04 ultrasonic sensor, you should come to this page. And then what you can see is I have a schematic which you can click on that will then allow you to see it a little bit bigger. There it is. Okay, and let me get a little further out of your way. Here. It's really pretty straightforward how we have this thing hooked up. What you can see is I am searching for something here on my desk. Give me just a second. Okay, I always like to look at this little card so that I say things right. So what you can see is we create a ground rail over here on physical pin 18 creates a ground rail. Then physical pin no, that's not right. It is physical pin 38. Physical pin 38 creates the ground rail, and then physical pin 36 comes down and creates the power rail. So we're getting the 3.3 volts out here. Now the HC-SR04, we have VCC coming down to the power rail. We have ground coming to ground. And now we have the trigger pin, and the trigger pin is going over to the most excellent GPIO pin 18, and then the echo pin is going to GPIO pin 19, so 18 and 19. Now I think last week we might have had it hooked to 16 and 17. I moved it to 18 and 19 just because I was kind of moving things over a little bit, and I ended up with them in a little bit different spot. Now, this is kind of what I think we were working on last week. I've just moved those pins. Trig now is, Trig is 18 and Echo is 19 over on the GPIO side. Then we've added this SSD1306. You can see that it's, from our perspective here, somewhat upside down. And why? Because I want to have, like, when the sensor is pointed that way, then when I'm looking at the display, I want it to be the right way. And so this is how I did it. Now you can see that SDA here, this N pin, SDA goes to GPIO pin 2, and then SCL or SCK goes to GPIO pin 3. And then VDD goes to power and ground goes to ground. So that is pretty straightforward, and hopefully you guys can get your circuit wired up without too much trouble, and that part will go relatively smoothly. Okay, now what do we need to do? We need to get our code, right? We need to get our code. And so let me switch over here, and I'll let you look at this for just a second. And then what we need to do is I need to call up where we ended up last week. Okay, so we're going to go back to last week's code, and it'll take me just a second to get that. So give me a second. Okay, yeah, so this is it. And so we're still on www.toptechboy.com. This time, precision ultrasonic distance measurement with PIO state machine on Raspberry Pi Pico W. And then this was the code that we developed. And so we're going to go ahead and grab that code. Okay, and then we're going to come over here and put it in. And this was the code where we were just seeing if we could measure distance. Okay, now I think we did make that one change. I'm also going to need to change, right? We said we changed the trigger and the echo pin. And so let's look where we did that. Okay, so the trigger pin was 16, but now that has become 18, and then the echo pin was 17, and that has become 19 because I moved things around a little bit. All right, so let me make sure that we're connected there. That looks good. Now, what I would like to see is, I would just like to see if the world, the universe is in proper working order. And so let's see if I can get a good view here. I think this would be a good view. Okay, so I'm going to set the target. I'm going to set the target right at the 0, and then I'm going to set this. I'm going to set the sensor right at the 15 centimeter mark, and then I'm just going to run last week's code to make sure that things work. And I run it, and it doesn't work, and I know why it didn't work. It didn't work because I had already hooked up this OLED, and therefore I haven't I haven't taken that into account. So I realize that really we would not expect that to work, but we can jump back over here and we can start getting ready to code this up. And so we're just going to assume it worked. I don't want to take it apart to show you that it works because I know that it does work. Okay, so what are we going to do? We're going to come in and we're going to get this little OLED. We're going to get this little OLED hooked up and working. So I told you already how that you get it plugged in. I told you how to plug the thing in. And so now what we're going to do is over here where we said that we imported pin, we also are going to need to import I2C like that. Okay, then what we're also going to have to do is we're going to have to say from SSD1306, we're going to import SSD1306 underscore I2C like that. Now you have to install that library, and if you have been playing along at home with us, and taken the other earlier classes in this series, you've already installed it. But if you haven't, you need to come over to Tools and Manage Packages, and you have to stop this thing from running. Tools, Manage Packages, and what you're going to look for is MicroPython underscore SSD1306. And so that would be like MicroPython underscore SSD1306. And then when you search on that, we're going to hope that something comes up here. Okay, yeah, MicroPython SSD1306. And it looks like there's two different ones. This is the one that I used here. Okay, so you get that installed. And then it should import correctly. Okay, so we've done we've imported the I2C and we've imported that from the library. All right, now what do we need to do? Again, there's that earlier lesson in this class. Go back and look it up if you want to understand this stuff better. But we've got to create our I2C object. Okay, so I'm going to call it I2C. I'm going to put a 2 on there, I2C2, sort of like R2, whatever that robot's name is, I2C2. And that's going to be equal to I2C, which is the method that we imported. And then that is on the I2C bus 1. And then that is SDA is equal to pin 2. And then it is SCL is equal to pin 3, because that's what we had in the schematic, right? And then we got to give it a frequency, and what works well is 400,000, like that. Okay, so that looks good. And how do you know that that is on bus 1? Well, if you have this little card in the SunFounder kit, or if you have the little, extended breakout of the Raspberry Pi Pico board, what you can see is that if I look at the GPIO, if I look at the GPIO pin 2, it comes out and it tells me that that is on I2C bus 1. And then that is what this 1 represents. There's like the 0 bus and the 1 bus. Okay, so that is pretty straightforward. Now we need to go ahead and create our display object. So I'm going to call mine DSP. You can call yours whatever you want, but that is equal to SSD, the library 1306 underscore I2C, okay? And then we got to tell it its size. This one is 128 columns, and it is 64 rows in pixels. And then what was our object? It was I2C2. That was our I2C object. So whatever you called it here, I called it here. Now, why did I put I2C2? Just because I2C might be a special word and uppercase I2C is and all this. So I just wanted to make sure I wasn't accidentally stumbling upon a reserved word or something that's used somewhere else. Okay, so that is good. And now we come down and we've already got the hard, heavy lifting done. We've got the hard, heavy lifting already done here with all of our state machine stuff. And so we're just going to leave that state machine stuff as it is. Okay, now when we come down here, what do we need to do? We need to display our answer on the OLED. All right, so what am I going to do? I'm going to say display text. And what text am I going to display? I'm going to say distance space, close the quote, then concatenate that with the string value of the distance that I just calculated, and then I want to put it on row 0, and then I want to scoot over just a little bit, like I'll go 16 over. And I think that is 0.16. When I run it, I'll have to see. I think that this is kind of the, I think this is row and then column. I think it's row and then column. And so we will check that out once it runs. So that was row 0, and then we'll come 16 pixels over so that it's not just pressed all the way over into the corner. Okay, so now that we've got that, what we want to do is we want to dsp.show that. So we've got it in the buffer. Now we got to show the buffer. And then I'm going to go ahead and I'm going to fill the buffer with zeros. Why do I do that? So next time through, I don't print over the earlier one where it's like, you know, you're just writing the same thing on top of each other. You want to kind of clear it out. Okay, so now we're going to keep our eyes down here. And I think what I'll do is I'll try to get something where you can sort of see. So I will set that up at 0 centimeters. And then I will set this up at, you see how this is all nicely ruled here? Okay, and then I will set this up at 15 centimeters. And then I am going to run this thing. And it doesn't like, what is that in line 6? What mistake did I make there? Okay. You see I got the error in line 6, and hopefully you guys caught it. I left that uppercase I, so it should be little I. Okay, now all eyes down here, and now what I'm going to do, I'm going to run it, and denied. Okay, now how many of you guys had this happen? That you got here, and what you can see is that down here I launched the pulse, and then once I launched the pulse, so I put this big number over to the state machine, and then it appears that the state machine pulls it in, and then somewhere between here and here, the code hung. Okay, now I will admit that I was not anticipating this when I gave you this homework assignment. And I will admit that it took me 3 days, like 3 days that were 12 to 14 hours long, to figure out why this thing didn't work. And let me ask you guys, stop and leave a comment, or if you're in the Premiere, leave in the chat that you ran into this problem or you did not run into this problem. Let me know. And then how long did it take you to figure out the solution, or did you just finally give up? Because I really was ready to give up because I could not figure out what was going on. So kind of like the first thing that I was thinking, is maybe it was just the power. Okay, maybe you couldn't power the sensor and the OLED at the same time. Maybe you couldn't power them at the same time, and therefore, you needed extra power. So then what I did was I brought in an extra power supply where I powered the SSD separately, and guess what? The same problem still happened. So I figured that it wasn't power. Okay, it wasn't power. And then I started thinking, well, does somehow the I2C interfere with the state machines, like maybe the state machines in maybe the library for I2C or the library for the SSD1306 is somehow interfering with the state machines. Like maybe they're both trying to use the same resources at the same time. So I spent like one solid day going down that rabbit hole, and that just was not able to fix anything. And so then I was thinking, okay, well, like if you've got this, you've got some of the pins are connected to I2C1, and some of the pins are connected to I2C0. So I tried to get the ultrasonic sensor on pins that were I2C0, and then the state machine on pins that were I2C1 to try to separate them. Then I thought, well, somewhere maybe does I2C trying to use the same state machine I'm using. So I tried to use all different state machines, and then finally, one thing I did was I just came in and I just disconnected power. The next thing I did was I just went in and I started commenting out all the things associated with the SSD1306. So I commented this out, this out, this out. I didn't import I2C, and then I commented all of these display things out. I commented out everything associated with the SSD1306, and still the thing would hang, even without loading the libraries. So then I came over here, and what I did was I came over here and I disconnected the SSD from power. I disconnected the SSD from the power, okay? And then when I disconnected it from the power and I came in and ran it, then I got a timeout. Okay, then the reason I got the timeout is because the rest of the code is looking for those the SSDs. So let me just see if I can comment that and comment that. And then I think I'll come down here and I will comment out these three lines. And so now what I've done is I've commented everything out associated with the SSD. And then I run it and boom. Okay, now it's working. Okay, so what is the only thing? I mean, what is it that you see? I'm not doing anything other than the only thing that I am doing is I am just putting power. All I'm doing is just powering up. All I'm doing is powering up the SSD. And then what happens? It breaks the state machine. Everything stops. Okay, you see, now it doesn't work. Did you guys run into this? What could possibly be going on? So then what I did was I put my oscilloscope on there. I thought maybe that little display was generating electrical noise. Maybe that display was generating electrical noise, and that electrical noise was then interfering with the state's machine ability to input the pins. Okay, and I thought maybe that was it. And no, I looked on the scope and I was getting really clean. I was getting really clean signal. So no electrical noise. Okay, so enough of this. What it is. Okay, this is what I started doing. All right, what I started doing was I put my scope and I was looking at every single pin. And what I noticed was that when I power up, not even calling it, but when you put power to the SSD1306 OLED, it brings up SDA, and SCL. It brings them high. And so over here at this GPIO pin 2 and 3, those signals are brought high. So those two pins now have a high signal. Okay, so this was what I figured out after 3 days. All right, this is where our problem is. Okay, when I said move the pins to Y, what am I thinking? What am I thinking? I am thinking it is bringing in the N base, which is the echo pin, which is pin 19, okay? Because that's what I have the N pin set to. But this is the dirty little secret. When you move the pins into Y, it goes and it gets all the pins and moves them into Y. I only wanted pin 18. I only wanted pin 19, which was the trigger pin. Okay, so the N base is the echo pin, that's pin 19. That is the only one that I wanted. But what did it bring in? It brought them all in. Now, why did the project work last week? Because the only pins that we were using was just that N pin, right? We weren't using any other pins that would be set, okay? So when I said, when there's nothing in Y, move on, it moved on because the only pin was that pin that we were reading, the echo pin. But now, when I plug this into power, that brings these two pins high. That brings pin 2 and pin 3 high. So when we read, when we move the pins to Y, Y has out there somewhere a 1 and a 1, and then all the zeros, and then the pin we're interested in, true, it is 0, but there is something in the Y register. What's in the Y register? Those two ones associated with SDA and SCL pins 2 and 3. Okay, pins 2 and 3. So the thing is that I just never run into this before, and so I hadn't thought. And what I realize now is this code is not going to work, because where is it going to block? It is going to be stuck in this loop. It's going to be stuck in this loop forever, because the SCL and the SDA pins are up. So what do we want to do? It's a pretty easy solution. So what we're going to do is we're going to come over here, and after the label, instead of doing a move, I'm going to do an in. Okay, and I'm going to go in, and in always brings it into ISR. It brings it into ISR. So I don't specify a destination, because the destination is ISR, but I specify a source. Where do I want to get the data from? I want to get it from pins. And then how many bits do I want to bring in? 1 bit. Where is it going to get that 1 bit? It is going to get that 1 bit from the N base. Now, if I had said 2 bits here, then it would have gotten it from the echo pin, which is 19, and then 1 more, which would be get it from 19 and 20. Okay, so now, what is the good news? The good news is that I now have the 1 bit that I want in ISR, where it does me absolutely no good at all. So now I'm going to move to Y, ISR. Now that is all good. Now what I need to remember now is this is going to take 1 clock cycle. Okay, that N is going to take 1 clock cycle, and then move ISR to Y, Okay, oh yeah, and we don't do this one, right? That one was the one that was the problem. Okay, so we move ISR to Y, and then this one's going to be one clock cycle. Okay, so now I have what I want, but I had to go through a path. I've got to suck one bit from pins into ISR, then move ISR to Y, and then if there's nothing in Y now, and the only thing that could be in Y is just that one bit that I pulled in, but if it goes down and there's nothing on that pin, then what am I going to do? I'm going to move on. So now this time, what has changed? I've got 4 clock cycles. Well, what I've got to do down here is remember the clock cycle. How many clock cycles is 4 times how many times I went through the loop. Yeah, you could see that. So in the earlier code, you go through, you have 3 clock cycles per loop. Now I've got 4 clock cycles per loop. So I get the number of loops, which I was counting, now times 4. And now that should be modified well. Okay, that should be modified. That should work well now. Okay, so is there anything else that we need to change? I don't think so. So now let's just see if this thing will run now. And so we're going to stop it from our earlier nonsense. And now let's see if we can run this thing. Boom. Okay, look at that. 17.3, 17.6. And so I'm sitting at 15. All right, I'm sitting at 15. And so I have a little bit, I'm reading a little bit high, but let's go down to 10. Okay, and that is reading about 12. So it seems like I'm reading about 2 centimeters long. Okay, I'm reading about 2 centimeters long or 1 centimeter long. So you see I'm over here at 30 and it is reading 31.3. So maybe I'm reading 1.3 centimeters long. And as I come over here, it is reading long. So it's like a fixed offset. I seem to be reading a little bit long, but I'm very convinced that my timing is right here. So one thing that we might do if we wanted more precision, right? Let's measure that pulse more accurately. Here, you can't see that, can you? Okay. Here, I'm running at 1 million clock cycles per second. So what I want is I'm going to make it go 10 million clock cycles per second. Okay, so it's going to be running through that loop 10 times faster. Well, because it's running through that loop 10 times faster, okay, it's running 10 times faster. I need to divide this. Should I divide there or up above? I need to divide here by 10, okay, because it is running 10 times faster. All right, now the other thing that I have to think of, up here, we want this, right? Up here, we want this to still be 10. We want this to still be 10 microseconds. And the way I've done it here is it would be like 1 microsecond. So what I got to do is I've got to add some more delays in here. So what I'm going to do is I'm going to make this to 32 minus 1 would be 31 plus this one would be 32. And now I'm going to do a no-op for another 31, which would really be 32, and no-op another 31, which would be 32. So this is going to be 32, 64, 64, 96. And then if I do a no-op 3, a no-op 3 more, which would really be 4, should make it 100, should make it exactly the right trigger pulse, and now more precision on measuring that echo pulse. Okay, so let's see. Like if you look back over here, you can see that we are at 10. Okay, we are at 10 centimeters, and now we're going to run this thing, and boom, look at that. Instead of reading 11.7, now I'm reading 9.8. And so that would be like getting the measurement accurate to within 2%. Okay, that is just really, really, really cool. Now, what else do we need to do here? Now we need to come down here and we need to take these out so that we could, okay, now we just understand better about how state machines work. Now we got to get the overall project working, and we're going to need to import that again. Now this time we hope that it keeps working, right? This time we hope that it keeps working. And let's make sure, I'm going to make sure that I got that power back on there. Good, I think. Okay, so now I put it at 10. Okay, and now let's see, what kind of view do we want here? We want to get this where you can see it. So I'm going to see if we can get this where you can see it. Okay, I think you can see that. So this time I want you to watch right here. And now I will put this at 10. I will put this, I'll put the target. So let's see. Right. This is what I have. All right. So now I'm going to run the code. And let's see what happens. Okay. So I am getting a, let me get this lined up. Okay. I'm getting just like just almost exactly 10 here. And then what do you see? Ah, look, something has come on my screen. Let's take a closer look, and boom, look at that, 10.16 centimeters. Now let me come to 15, and you'll just have to trust me that I did that well, okay? And what is it reading? It is reading about 15.7, 16.1 there. That is pretty good. I'll come back over here. And now we have a glare, so you can't see it. So let's put it right here. Okay, and look at that, 15.7. when it is at 15. So it's like within, it's really within just a fraction of a centimeter to being accurate every time. It's within a fraction of a centimeter to being accurate every time. And so look at that. We have this thing working now. Okay, guys, I hope that you have enjoyed this lesson, and I hope that you've learned a lot from it. And I think that we have, we sometimes learn from surprising things. And I hope some of you guys actually worked through this and got it figured out. Now, where could you go from here? Where you could go from here is, remember that if you save the program as main.py, then you would be able to, just whenever you powered the Raspberry Pi on, it would run this program. And then what you would need is you would just need some sort of battery unit to make it work. And so you could think about, I think the Kepler kit has this little battery unit. You might try powering this with the battery, and then you should be able to walk around. Now remember that when you put the battery on there, you've got to not just power up your ground rail, you need to bring it in. And I think it's pin 39 that you can bring the power in. And this would actually plug into 38, 39, and 40 over here. And so that should power this thing up and power your project. So you can try this. I don't like this one very much. If you have the Elite Explorer kit from the Arduino the Sunfounder kit, you have this little battery module. Okay, you have this little battery module, and this one works a lot better. So if you really wanted to go portable, this would be a great way to do it. But I'm not going to do that because I can't really walk around and you see me, but I did try it and play with it, and it worked very nicely. Okay, guys, I hope you are having as much fun taking these classes as I am having making them. It's at this point that every week I give a shout out to my Patreons who are standing with me. And I want to give you a great big thank you, because the type of in-depth lessons and advanced classes that I'm giving, I don't get millions or hundreds of thousands of views. I get a few thousand views. So the only way that I can continue to make this in-depth content is because of the help of you guys on Patreon. So I want to thank you for that. You can also help me by giving a thumbs up on this video and leaving a comment down below. If you haven't already, subscribe to the channel, and when you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people working on engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.